Okay, so by popular request, Hubeida's asked me to go over this paper. Now, unfortunately, I can't annotate that, but I can talk you through this arrangement. It's not too difficult. Most of it's okay. It goes up to grade 9 in places, so you're really going to have to listen to what I say, because even if I was to put this on my Mimeo class worksheet, I still can't write on it. With a mouse, it would be squiggly, it would be terrible. So you've got to listen really carefully. So those who are interested, this is the Circle Theorems mini assessment that I set for you guys. I will upload it, save it, and give you the link, all right? So, blah, 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 too much to read. You can read that. You got it in front of you. I don't. Use the diagram to answer questions 1 to 3. How big is angle CAB? CAB. Well, look, that's a diameter because it passes through the centre. So that's 90. So these are 45 each. So CAB is 45. Job done. What is the size of angle ECD? ECD. They want this one. Well, if you look very carefully, it's going to be 65 degrees because that's the alternate segment theorem. Is that okay? So angle there equals the angle right there. So 65. They don't ask you to have a reason, not for these starter 1 markers. Either way, it's going to be 65. Is it there? That's a relief. Work out size of angle BCD. BCD. Well, that's 45. That's also 90 because it's a triangle that is forming an angle of 90 at the circumference, because that's still a diameter that's shared by these two triangles. So we've got 65 and 90 comes to 155, which gives me 35 in there. Or is that maybe 25? Let's go for 25. So 25 and 45 should come to 70. I hope it's there. Well, just believe me anyway. That's the theory behind it, okay? So 45, 90, that's the leftovers. I think I said it was 25. So 25 and 45 is 70. And that gets a little bit more difficult. Work out obtuse angle AOC. That's this one right here. Not the one outside there. That one right there, okay, Obeyed? Well, you may remember, if that's 118, then ABC is going to be 360. Sorry, 180 take away 118, which is, I can't do it in my head, 62? Yeah, 62 degrees. Why? Because it's opposite angles in a cyclic quadrilateral sum to 180 degrees. If that's 62, this must be AOC, twice the size of 62, because the angles at the circumference are twice as big as the angles at the angle at the center is twice as big as the angle at the circumference in the same segment. So here we are. Imagine the line from A to C. AOC and ABC are in the same sort of part of the triangle. So we double the 62, comes to 100. I'm so tired. What's 120, 128? Something like that. 260, 120, 128, or 124. 124. Anyway, you do the math. You've got a calculator. I'm exhausted. What's this? So this is a grade 9 proof. Okay. That's a radius. That's a radius. That's a radius. If that is x, that is x. If that is y, that is y. Therefore, angle BOC must be 180 take away 2y. You should write that down. And angle BOA must be 180 take away 2x's, okay? So I've got 180 take away 2x plus 180 take away 2y. Now, if you simplify that expression and subtract that from 360, you would get the angle of AOC. In fact, you get an answer of 2a plus 2x plus 2y, which is 2 bracket x plus y factorising. The answer to quote circle theorems, which is isosceles triangles, isn't it? And of course, yeah, that's it. So x, x, y, y, 180 take away 2y, 180 take away 2x. Add up these two parts, and you will get, I really have no idea, 180 take away 2x plus 180 take away 2y, which is going to be 360. Anyway, I can't do it unless I write it down, and I can't really show you it anyway. So that's the theory behind that. It's very straightforward if you think about it. What about this one? CDE. CDE. They want that, do they? Oh, okay. Well, ABE is 57. So guess what? ACD is also 57. Why? Angles in the same segment are identical. If that's 57, that's 57. But hey, look, we have an isosceles triangle. If that's 57, then base angle DCE and base angle DEC are the same. So that's 57 and that's 57, which takes us up to 114, 188, take away 114, which is roughly 66. something like that. Anyway, you do the math. So angle CDE is 66. Why? Well, that's an isosceles triangle, and angles in any triangle sum to 180. Amen. Done. What about this? This looks terrifying. It's really, really not, you know. So these are tangents, blah, blah, blah. If they're tangents, you know what? A tangent to the radius is 90 degrees. So DBO is 90, DCO is 90. 90 plus 90 is 180. Plus 60 is 240. Which leaves us how much from 360 being a quadrilateral? I think that's 120. So BOC is 120, which means that AOC must be 60 degrees. Why? Angles on a straight line and up to 180. So AOC is 60 degrees. But wait a minute. This triangle is also isosceles in as far as these two radii come from the centre of the circumference. So if that's 60, then we're left with 120 degrees to share out amongst angle OAC and OCA. So 120 divided by 2 is 60. Oh, all the angles are 60 degrees. So you write down AOC equals 60. OAC equals 60, BCA equals 60, and you get your 4 marks. And I think I've done it. That weren't too hard. I feel really frustrated not being able to actually write and annotate and show you my thinking, but I don't have the facility. I'm so sorry. Right, I'm going to call that done. I'm going to upload it to you, Ubaid, and everyone else who wants to look at it. And yeah, see you soon.